Hello everyone, I'm Hunter Will, and today we'll be covering Lab 2 of your CS110 program. Okay, so we're going to be looking at C++ program structure, simple input-output, and primitive data types. Okay, so we're going to create your own Visual C++ project, compile and run the program, compile two different programs in one project, and then capture the program output. Okay, so the C++ program structure, there are two basic parts. Okay, the first part is instructions to the instructions to the C++ preprocessor and compiler, and then instructions that describe the processing to be done. However, before we can describe these instructions, we must have a way of naming things so that we can tell the compiler about them and describe what we want to have done to them. Alright, so we name things, data types, data objects, and actions by giving them an identifier. An identifier is made up of letters, numbers, and underscores, but must begin with a letter or an underscore, okay? You can't just throw a number or a symbol on the beginning of your identifiers, okay? So we use the words identifier and name interchangeably. Alright, so let's keep in mind that C++ is case sensitive. It means value, 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 and value could be 4 different identifiers, alright? So it's not like other programming languages where if you were to do type in these 4 different identifiers, it would understand that that's the same thing. C++ is not like that. It wants you to be very specific about what you're typing in and what you're saying. Okay, so let's look at this program right here and break it down a little bit. So line 1 to 9 is a block comment. So a block comment, or like a header comment like this, is usually used to describe who wrote the program, what is the purpose of the program, and what you named the program. Alright, so in this case it's sample.io.cpp, the author is Ada Lovelace, and the purpose of this program is to demonstrate basic input-output operation by inputting a number and outputting the number just entered. Alright, pretty straightforward. So now let's talk about this hashtag include IOStream. What this hashtag include is doing is we're saying we want to use the commands from the input-output stream header file. Alright, so we're using commands from the input-output stream header file. And then what line 12 is saying is we just want to use the standard portion of that header file. So we're going into that library, grabbing the standard portion of that library so we can make coding a little bit easier. So these two will probably be in every program that you use this semester. On line 14 we say int main. Int main is the executable part of our program. Alright, so anything past these in between these curly braces of int main is the part of the program that will be run. So if I say integer number, I want to create an empty box called number, and then and this number box can expect a data type integer to be stored inside of it. Alright, so that's what we're doing right here. We're creating a variable called number, and it's expecting integer data type. This cout, or count, says please enter a number, and it's what it would do is it'll print to the screen that the user is using and be like, yo, please enter a number. It'll say please enter a number. This is how we display what we want the user to do, or prompt the user for information, or explain to the user what's happening. Cout is how we show the user what we're going to do. Okay, and then sin, or cin, number. So this is how we store what the user types in into our variable. Without the cin, number wouldn't be able to get anything stored inside of it. So we need the cin to get input from the user and store it inside of number. Now, we finally have one more count that says you entered. It will say to the screen you entered, and then it'll say the number that we entered in the previous step. And this end line is just a fancy way of like, it's a way to format the screen better so we don't have everything squished together. So we'll just add a blank line in your output. Alright, and then we have return 0. So let's copy and paste this program, and I'll show you what I mean. So I'm going to open up my Visual Studio. I'm going to go through this with you one more time. I'm going to click New Project, Windows 32 Console Application. Do not create a directory for solution. Name it whatever you want. Number. We'll say enter a number. Okay. Click Next. Check off Empty Project and hit Finish. Cool. We have our empty project. We click Project, Add New Item, CPP. We'll add source.cpp, hit Add. I'm not going to bother naming it this time. And then we'll go back to this code and copy and paste it. So what should ideally happen when I copy and paste this code is, and try and run it and build it, is it'll ask us to enter a number, we'll enter the number, and then it'll display that number to the screen. Alright, so I'll click build, enter a number. It built successfully, so we'll hit debug, start without debugging, and then I'll enter a number 15. Make sure to click on the screen so you can actually type, because that's what I did not do. There we go. You entered 15. Okay, it's a very simple program that just asks the user to type something in. Okay. Moving on, we're going to look at C++ basic input and output. Okay, so this count and cin are both special variables. So use along with the insertion operator to write out the values of variables and expressions to the standard output device such as a screen. So that's what we do in this program right here. We use cout to write this expression to the screen, and we could also use it to write out what's stored inside of this variable to the screen. And that is thanks to the help of this insertion operator. So a good way to remember which one is which, remember that cout works with the insertion operator to insert something to the screen, and then cin works with the extraction operator to extract data from the user. Alright, so this will get information from the standard input device such as the keyboard, and then the extraction operator uses the fancy background computer work to store stuff that's on the left side into the stuff on the right side. So it takes two operands. Its left-hand operand is a stream expression, e.g. just a stream variable cin, so it could be like getLine or something like that. That's what could be on the left side. So we'll learn more about that in future labs. Its right-hand operand is a variable into which we want to store the input data, so in this case before number. And then we can do this several times though. So if we have multiple variables, we could just do one cin and then a lot of extraction operators between to get multiple input in one go. Okay, now we have simple data types. So simple data types are short, int, long character, unsigned short, unsigned, unsigned long, and unsigned character. And then there's also floating types, which is float, double, long double. Okay, the main difference between integral types and floating types is that integral types can't take decimals. Floating types can have decimals. Alright, so floating types are much better if you want to be precise or be very specific with the calculation. And integral types is if you want to save space and optimization in your program and you don't need to be as precise. Alright, because when you create an integer variable, it takes up less space than a double. Alright? So here we're going to talk, this is how we declare a variable. Alright, when we declare a variable, we're telling the computer to set aside a space for that variable. Alright, so if I say character letter, I'm telling the computer to set aside some space for an empty box so it can actually be filled eventually. Alright, so we have character letter, so we're telling the computer to set aside some space for this letter character, and just in case we might store something inside of it. Same with this integer x, long, float, double, and bool. So as you can see though, we can create variables, or as we said before, names and the other word I am forgetting right now, identifiers. Alright, so we can name identifiers whatever we want, as long as they don't start with a number. Alright, as long as they start with a character or an underscore. So we have this identifier letter, x, student ID, okay, identifier, variable, the same thing. Now, we're using different data types, so we're setting aside different sizes of spaces for this computer, for this program. So I didn't mention bool before, but bool is just a data type that can be true or false, 1 or 0. Alright? So now that we've declared these, we haven't stored anything inside them. Alright? So when you're running a program, when you declare it, make sure it is initialized at some point when you use it. Alright, I'll show an example of that actually right now, after this initialization expression. Okay, so we declare variables, and then we say, hey, we want to initialize them. I want to store something inside of my empty variables, alright? So these are all empty, and now we're storing something inside of them. So letter I'll store A. As you can see, we use single quotation marks. Okay, that's how we say something is a character. If we use double quotation marks, we're saying it is a string, and that is not the same thing as a character. After that, we say x equals 7. Student ID equals this, da 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 da. Alright, so what we do is we use each variable's name and identifier and say it equals this other thing to store something inside of that. So now if I were to ever say cout letter later on in my program, it would output the letter A because we stored A inside of it. Okay? And then, so what we don't have to declare and initialize on one separate line. We can just do it on the same line. Alright, so this is the same as, this area right here is the same as these two steps. Okay? So as you can see right here, there's a little bit of a warning. However, a variable can only be used after its value is set. So let's take a look at this program right here. So I declare number, and then I initialize number with this cin. Alright, so this is another way to initialize something. So cin is a way to initialize your number. But if I were to comment this line out, number isn't getting initialized, but I still try to output it. So when I build it, as you can see, I get an error. Alright? Initialize local variable number. So when it says uninitialized, that means you didn't put something inside of your variable. Okay, moving on. We can also do something called const. So what you do is you just throw const on before your data type and variable name, and then the computer will be like, well, I'm never going to change that number. That's all a const is. It's just a number that's never going to change. Arithmetic expressions. So with coding, we can do some simple and basic arithmetic expressions. Alright, so we can do addition, subtraction, multiplication, division, modulus, plus plus, and minus minus. So this is basically add one and subtract one onto whatever you're doing. Okay? The rest of this is just your normal math. The only one I think that would be unique to most of you is modulus. Modulus is how we return the remainder. So if I were to do 5 modulus 2, the remainder would be 1. Alright, because 2 goes into 5 2 times, and then there's a remainder of 1. Okay. And so when you're working with math and you're coding, make sure that you include a lot of brackets so you make sure the math does the way it does. Otherwise, it does just follow the normal order of precedence, okay? So how this list is organized down on a different page shows what the order of precedence is, alright? And that's how the order the computer will go through when it's doing its math. So we'll do multiplication first and then addition. So if you know your PEDMAS or BEDMAS, so brackets, exponents, division, multiplication, addition, subtraction, you shouldn't have any issues. So like, for this case, it would be 3 times 5 is 15, plus 4 is 19. Right? And then this one would be 4 plus 3, so that's 7 times 5 is 35. So the first two answers is 19 and 35 if you follow BEDMAS. Okay? So we can convert numeric types later on in the program. So say you wanted to store a floating point number into an integer number. Alright? There's two ways we can solve this issue. We can do type coercion or type casting. Alright? So type coercion was when will implicit or an automatic conversion will happen. We won't explicitly say for it to happen. And then type casting is when we explicitly say to convert a data type to something else. So if I go to this int value 10.66, int value equals 10.6, assuming int value is of data type int, what will happen is this will be implicitly casted and result in 10 being stored inside of an integer, alright? Because integer data types cannot take decimal places. So what they'll do is they'll just cut this off. Alright, they'll just completely cut off the 0.66. They won't round up or round down. They'll just cut it off. So it'll just be 10. And then if we were to say int value equals int, this is called type casting. This is where we explicitly say I want to cast this data type float as an integer instead. Alright, so this will just still do the same thing though. It'll just cut off the 0.66 and result in 10 being stored inside of int value. Alright, that's the difference between type coercion and type casting. Type casting, we say what data type we're going to use, and then type coercion. It does it on its own. The computer will basically try and figure it out figure out what you want. The computer will try and figure out what you want on its own. Okay? So something you might end up doing is, say you're working on a program though. So this is not related to arithmetic expression, simple data types, or anything like that. We're going back to your Visual Studio 2015 and looking at more about how to use it better. All right? So, freezing up hard. Freezing up hard. Okay. Let's say we had two programs, right? If I hit add new item, CVP, add. Right? As you can see, we have source1 and source1.cpp, but source1.cpp is empty. All right, let's copy and paste this program into the other one. Right, if I try and build this, as you can see, we get an error called main already defined and source.object, or one or more multiple defined symbols found. The reason this happens is because source and source1 both have int main inside of it, which causes issues. So if you wanted to work on another .cpp file, alright, what you have to do is you have to right click and remove one of the files. Alright, you can delete it, which will get rid of it forever, or you can hit remove. Alright, so now I only have one file. I can click build, and build, enter a number. Okay, there we go, the program built, and I don't have any issues. Now, if we go back to this website, what if we wanted to add that program back in that we were working on? What you can do is you can click on project, add existing item, and then you can add the .cpp file back in. Just click add, there we go. And now we can go back to working on the previous program, but just make sure if you wanted to run either one of these programs, you would have to remove at least one of them. Okay, so this is how you work with multiple .cpp files. But say you wanted multiple projects. Alright, to open up multiple projects, what you don't do is don't click File, New, and Project. Alright, what will happen is it will store this new project inside of your old project, and then you'll have all of these folders inside one of another, and you'll have to like go through and sort all of them, and it's not a good time. What you want to do is you want to go down to your Visual Studio here at the bottom of the screen, right click, and click Visual Studio 2015. This will open up a completely new Visual Studio app, and you can create a new project from scratch. Alright, if you have any more questions about how to use projects or how to cycle through them, you can look at Visual C++ Program Management, and it should be able to answer any problems you have if you run into an issue when trying to work with a program or add a new project. Okay? But for the most part, keep it simple. If you want to work on a new project, right-click Visual Studio, open up a new project as you would normally. If you want to add another .cpp file in an existing project, click Project, add existing item, and then go find that .cpp file you want to add. Okay? So, before I end this video, I just want to show you that if you want to change your Hercules password because you don't like it, you can click Change Hercules. Alright? This will take you to a link, and then you can change your Hercules password. There's also how to print. The script command, we discussed that last week. The compile we did last week. Using Nano, we did that last week. Alright? So something you can read through on your own, though, is the Unix file structure. Alright, so this is how files are used in Unix and how it like branches out and how the trees are worked. Alright? This will give you a lot of information and hopefully answer some questions you had when you were looking at the Unix last week. But something I'll do quickly before I end this is go through some basic Unix commands. Okay? So, as you can see, I have my PuTTY configuration opened here, and here is the hercules.cs.uregina.ca link that I saved from last week, so we can just double click on that, and it will open up hercules.cs.uregina right away. And since this is our second time opening it, we do not have to deal with that security pop-up. So we enter in our information. Okay, So some basic Unix command, one is ls. Alright, when I type in ls, you see all of this information. Alright, as you can see though, these blue ones are directories, or as you're most familiar with them, are folders. In Windows, it'd be the equivalent of a folder. It's something that can store more inside of it. So if I wanted to see what was on my desktop on my Hercules, I could type in cd desktop. Alright, okay, so what cd means is change directory to desktop. Alright, I am now inside of my desktop. If I wanted to see which directory I was in, I could type in pwd. Alright, it says I'm in my Hercules account, HR596, inside of the desktop folder. If I wanted to see what's inside of the desktop, I could type in ls. It'll just show the binary tree. And if I wanted to see if what I had access to in this, I could type in ls-l. Alright, and this will say the last time I accessed this binary tree folder. Alright then, so what if I wanted to go back to the previous directory? You can just type in cd, and if you type in ls, you can see that you went back one directory. Alright, cd and ls and pwd are like a lot of the commands you'll use when working in Hercules, and they're the main ones that allow you to navigate. Of course there's cc, but that's compiling, which is on the website and discussed in last week's video. So if you want to look at more Unix commands though, and get more familiar with it, you can look at this list of Unix commands or Unix tutorial for beginners. Alright, if you type in man before a command though, it will open up the manual on that command and explain it. So if I type in man rm, it explains how manual rm works. And if I wanted to exit this, I can type in Control X. If you type in Q, that's how you exit the manual. Now RM, what it does is it removes a file. It doesn't remove a directory, it removes just a file. So let's remove from last week my header.txt file. If I type in rm header.txt and type in ls now, as you can see, my header.txt is gone. As you can see though, the screen is kind of getting messy and filled up with a lot of commands. If I wanted to get rid of all these commands, I can type in clear. Right, it doesn't delete or undo any of the steps you just previously did, it just empties the screen so you can see again. Alright, and then you could use the mouse, the arrow keys, to scroll through previous commands. Alright, and so that is all I'm going to show for some basic commands today. If you have any questions, just go view last week's video on compiling and entering programs. To exit PuTTY, just type in exit, and you're all logged out. Alrighty. If you're still having troubles getting Hercules on your computer, you can look at Windows to Hercules. This will help you download PuTTY, and then this will help you download WinSCP. What WinSCP allows you to do is move files from your current computer to your Unix server. I will do a separate video on that just because I don't want you to feel overwhelmed, and then I'll also go into more specific details about Unix. Now if you go to Mac to Hercules, there's something called CyberDuck. I personally have never used CyberDuck, so hopefully the instructions here provided to you will be enough to help you get set up for this semester with working with Hercules. Alright, so thank you for your time and have an excellent day.